So let's try to put numbers in this equation so that we may get some insight. So for example, P1 is equal to say 20 pascals. So this whole thing is 20 pascals. So this should also be equal to 20 pascals. So whatever pressure you transmit here, 20 pascals, it must be equal, it must be undiminished when the fluid pressure exerts on this car. So we know that your force is very small. So for example, in order to achieve 20 pascals, you only have what do you call that? For example, you only have 40 newtons. So you will be applying it on an area of 2 meters square. So we know that the force of the car is very big. So for example, I don't know how big yet, but for the sake of insight, we say that it is 40,000 newtons. So we should also have a pressure of 20 pascals. So the area here must be very big also. So this should be 2,000 square meters. So that 20 pascals is still equal to 20 pascals. So as you can see, there is a trade-off between the area applied and the forces. So let's try to solve an actual example here. So in a hydraulic lift at 120 centimeter diameter piston supports a car. So this is the 120 centimeter diameter piston that supports a car. If the total mass of the piston and the car is 3,200 kilograms, what should be the diameter of the smaller piston, this one, if an applied force of 450 newtons is to maintain the system in equilibrium? So let's write our equation. P1 equals P2. So F1 over A1 equals F2 over A2. Okay, so what is F1? F1 is 450 newtons. A1 is unknown. So we should be able to solve the diameter of the smaller piston. So since this is a cylinder, its cross-sectional area is the area of a circle. So this is pi r square. So this is A1. So this should be equal to 3,200 kilograms. So this is just mass times 9.81 over this cross-sectional area for the car is 100 has 120 centimeters diameter. So this will be pi. R is actually d over 2 square. Okay, so we can actually cancel out the pi's here, and rewriting the equation, we have here 450 newtons times d, so let's call that d1 over 2 squared equals, so simplify this one, 31,392 newtons over the diameter is 120 centimeters over 2 squared. Okay, so our only unknown here is d1. So solving for d1, you should get 14.37 centimeters. So 14.37 centimeters should be the diameter of this piston. So this is very much smaller compared to the diameter of this piston, which is 120 cm. So again, there is a trade-off between the force applied and the area. So this is how Pascal's principle works in hydraulic lifts.